Now let's look at some examples of problems that relate to this inverse trig information. Let's suppose that we were asked this problem. Let's suppose we were asked to evaluate inverse sine of 1/2. Now, what this is asking for, it's asking for an angle whose sine value is 1/2. Now, it could also be written this way, arc sine of 1/2. In other words, from out here on the arc, where the y value is 1/2, what angle corresponds? In other words, what is that angle right there? That's what this is asking for. So these two things, these are just two different ways of, two different notations. Now, what we would do is we would look and then see, okay, I've got a 1/2 here. What angle does that correspond to? Well, it corresponds to 30 degrees. Okay, of course, both of them, 30, they're the same thing, 30 degrees. Now, you might say, well, wait a minute, over here at 150 degrees, that's also equal to 1/2. So shouldn't we say then that inverse sine of 1/2 is 30 degrees and it's also 150 degrees? See, those two things, you could argue that way. But no, you have to be specific. When you're using this in notation, when you're talking about the inverse, the output for sine has to be between negative 90 degrees and positive 90. So 150 is not going to be a part of that. The only answer, inverse sine of 1/2, is 30 degrees. That's it. Because sine has to be between negative 90 degrees and positive 90. Or, pi over 2, negative pi over 2 and pi over 2, if we're dealing with radians. Now let's look at another example down here. Let's suppose that we have inverse sine of negative 1/2. Okay. Now, actually, sine has an output of negative 1/2 in quadrant 3 and in quadrant 4. Both of those. What we want is the angle that corresponds to a sine of negative 1/2 that is between negative 90 degrees and positive 90. Now, if you look at this, let's look at this angle right here. You can see that angle, this negative 1/2 corresponds to a negative 30 degree angle. Now, a coterminal angle to that would be 330. So in other words, if we go around this way, that would be 330. But the output, specifically, if we're talking about inverse sine, it's going to be negative 30. It's not going to be 330 degrees or anything like that. It's very specific. When you're talking about inverse sine, you have to use that. Now notice I didn't even use the angle over here in quadrant 3. Because there is an angle in quadrant 3 where the inverse sine is negative 1/2. But I don't care about that. I only care about these intervals here. So that's the way we do sine, cosine, tangent. Those are the three we're working with. We pay attention to where the outputs, what are the range of the outputs. Okay? Now, so you can be asked to evaluate functions for sine and cosine, tangent, the inverse. Inverse sine, inverse cosine, inverse tangent, like this. So for example, let's suppose, back here on this one, let's suppose we were asked to find inverse cosine of negative square root of 3 over 2. Well, cosine is going to be between 0 and pi. That's its output. Or between 0 and 180 degrees, however you look at it. So this one, we're looking for where cosine is negative square root of 3 over 2. Well, that's going to be right here. That's going to be 150 degrees. Now, there's also a place in quadrant 3 where cosine is equal to negative square root of 3 over 2. But we have to be between 0 and 180. And we could look at some other examples. We could say, well, what about arctan of negative 1? Okay. In other words, what angle do we take the tangent of to get a negative 1? So we look around the unit circle. Okay, so we have a unit circle here, and we're looking for where sine and cosine are the same. Okay, so right here at 45 degrees, at all the multiples of 45, that's where we have them the same. Now, we're looking for where sine and cosine are opposites. So, in other words, square root of 3 over 2 and negative square root of 3 over 2, that sort of thing. So, that would be quadrant 2 and quadrant 4. See, over here you have negative square root of 2 over 2, positive square root of 2 over 2, tangent, sine over cosine, that's negative 1. And down here you have square root of 2 over 2, negative square root of 2 over 2. The tangent here is also negative 1. So the question is, well, which one do we use? Do we use this one or this one? Well, remember, tangent is going to be between negative 90 degrees. The output's going to be between negative 90 and positive 90. Notice it's not including the 90. Or I could say between negative pi over 2 and pi over 2. It's very specific. So this is going to be negative 45 degrees. Okay. It's got to be between negative 90 and positive 90. Okay, so that's the way tangent is. Now, so those are ways that you can be asked questions about inverse trig functions. You can be asked to just flat out evaluate them. Well, here's something else. Here's something else another way we could be asked a question. Let's suppose we want sine of arctan of, let's say 4/5, something like that. The sine of arctan of 4/5. And let me do this. Let me change this a little bit. Let me make this 3/4. Okay. We want the sine of the angle whose tangent is 3 over 4. That's what we want. So this arctan of 3/4 is just like theta. This is just like we're saying sine of theta. But we're given a little bit more information about theta. We're told theta is such that the tangent of theta, the adjacent over the opposite over adjacent is 3/4. In other words, let's just look at this. Look at a right triangle here, and we've got theta, which is arctan of 3/4, and this is 3 and this is 4. So we're asked to find the sine of that angle. So I just made a triangle. I know that tangent is opposite over adjacent. Now this up here then, using Pythagorean theorem, would be 5. So this would be the tangent of that, the sine of that angle, which is 3 over 5. Opposite over hypotenuse. Now we could have something like this. Let's suppose that we have the tangent of let's say inverse sine of x over x plus 1. Let's suppose we had something like that. So we want the tangent of that angle. Well, now remember how this goes. So we have a triangle. I'm going to make a triangle. And this angle here I'll call theta. Okay. Now the opposite over hypotenuse. There's what we have right there. Opposite over hypotenuse. And we'll pretend this is a right angle. Now, I use Pythagorean theorem to find this other part down here, which is the square root of x plus 1 squared minus x squared. Okay? Okay. And let's go ahead and simplify that out a little bit. This would be x squared plus 2x plus 1 minus x squared. So just make it a little bit better. This would be 2x plus 1. See? So what we have here then is we have the tangent is going to be x over the square root of 2x plus 1. See? The key is you just think of this as an angle. And that's the way we do. That's, a couple of main ways that you can be asked about trigonometric inverse functions.